Alright, so we meet again in the next part two. Part two. In this part two, we will examine more about the three function. Left we have trigonometry, we have exponential and algorithm, and all these three function we will implement that from the last method we learned in the last video about the different integration using substitution. Alright, so just a moment, I want to share my slide and our screen. Okay, share screen. Right. Alright. Oh, sorry. Okay. Right. So in last video, I have shown to you how can we uh, apply to apply the first method of integration, which is the substitution method, and we have four simple step. Is first step is you have to choose u, and in the algebraic function we'll mostly choose u in the with the function with power n. Okay, n here can be negative, can be positive, or in a fraction form. Right. So next we continue with the three more function: trigonometry, exponential, and logarithm. Alright. So for first one, we go for trigonometry. So for trigo, we just cover only two. So, right. So if we have the function of y is sin x, so we want to integrate sin x with the x. So x here is our angle, and it is belong to sine. And we can simply write the answer is negative cos x plus c. Okay, and second function for cosine x. Okay, we have integral cos x, we will have sine x plus c. Alright, so I have seen some, not you, your senior, so they mistake use the algebraic function into trigonometry. So what they did is they do like this one. They did integral, so sine x 1 plus 1 divide 1 plus 1 here. So this one is wrong. Don't do like this. Why? Because we have sine trigonometry. So when we have sine, you need to refer to the table of sine function here. And don't worry, this one you don't need to remember or memorize, because in the exam or test, all will be given, right? So you just need to know where to use and how to use the integral. Okay, right. So, but okay, next, in this level of course, we have one limitation or restriction, is whereas the angle in this x or angle for trigo must be linear, or we can say that the highest power of x is 1, not 2, not minus 1, but 1. Cannot solve other than that. Okay, if you query why, because if we have sine x square, it will keep producing the series. The integral will not stop. Keep doing the integral, not stop. So that's why in this level of diploma, we just examine the trigonometry with the linear function. Alright. Okay. Now we go for much more fancy example. Right. Okay. So now I want to implement, okay, the method of substitution into trigonometry function. Right. So let's say I pick one things. We have one issue or one problem here. Integral of sine 2x, okay, dx. Right. So we have one function of trigonometry, which is sine 2x. Right. So now we apply back what we have learned last video, which is the integration using method of substitution. Okay, method of substitution, in short, subs. Right. So remember, first step is we have to choose u. Right. Step 1, again, I just quick refresh. Step 1 is choose u. Right. So for trigo, most of the case we will choose u that is u in trigo is our angle. So in this case, our u is 2x. Okay. So we will let u equal to 2x. Let u equal to 2x. Alright. And then we can rewrite the integral in terms of u integral of sine 2x. Sorry, sine u, my bad. Sine u dx. Right? Okay. Step 1 is done. Next, we go for step number 2. Again, try to recall the name. Step 2 is we have to rewrite dx to du. We want to change the x here to du, which means we have to use back our knowledge in chapter number 1, or differentiation of u will give us du over dx equal to 2. So 2 we will get here from chapter number 1, differentiation. Alright? Recall your notes. Next. So from the algebra, we will get dx is equal to du over 2. Okay, so rewriting the integral will by replacing the x with du over 2, we get the integral sine u du over 2. Right, move on. Number 3 is solve the integral. Okay, integrate. Okay, so I take back the integral from number 2, step number 2. So bring to step number 3. So we have the integral sine u over du. And just like before from the last video, we can always bring 1 over 2 either here or outside, become 1 over 2. Right? Okay. So now we want to solve this problem, sine u du. So from our earlier, we have known that sine u or sine x dx become negative cos x. If I switch the letter or the variable, like instance sine u du will give us negative cos u plus c, which means in this example, we will write the answer of the integral become 1 over u in bracket negative cos u d3 plus c. Okay. And lastly, number 4, step 4 is we just put back the u by replacing what we have let earlier to x. So the answer will be -1/2 cos 2x plus c. And that's how you apply the method of substitution into the trigonometry function. Okay, so here I have 3 examples. So try from what I have shown earlier about how can we implement the method of substitution into the function of trigonometry. Okay, so we have 3 questions, 1, 2, and 3. Okay, at least you can try, you can solve, or you will get better understanding if you try these 3 questions. Alright? Okay. Alright, so I hope your brain still can process, can receive the new knowledge or new things today. Alright, so you can pause the video or you can rewind the video to listen back, to relearn from this method. Alright, good. Okay, so if you are ready, now we want to enter the second function for today's. Is the most easiest one is exponential function. Right, so beforehand, I want to show you a meme. Okay, so alright, so take a look of this meme. Okay, so we have learned in chapter 1 that the differentiation or gradient of ex function will give us the same answer ex. Okay, so same with the integration of ex, we will get back the same answer of ex. Alright, so if you can laugh, I will say, with this meme, I can conclude that you understand the function to integrate as well as differentiate for e function. Alright? Okay, so if we have integral ex with the x function, we will get back the original function ex plus c. But since it is in the part of integration, we must always put the plus c sign. Right? And again, the limitation in this level of study diploma, we just examine the power of e here must always a linear function. Okay, or the highest power of x is 1. So linear can also be written in the form of ax plus b, whereas a and b is a constant, a number. Alright, so now we want to apply again the same method of substitution but into the e function. Okay, right, so example here, let's say we have integral to e 3x minus 1 with the x. Right? Okay, so we have 2 as our constant. So we can rewrite by bring out the 2 constant 2 in front. We have 2 integral e 3x minus 1 dx. So you can bring number 2, these two, outside or inside, no matter. Okay, but it will give us same answer, not sure. If you want to stay put or you want to bring outside, up to you, your own choice. Okay. Now, from the method of substitution here, we apply again method of substitution. Okay, ingat, remember step 1, we need to pick u. Alright, so for e function, most of the case, u is the power of e. Okay, right, so we will pick u, so we can say that let u equal to 3x minus 1. Okay, and we can rewrite the integral, the blue part, and we will replace the 3x minus 1 with a symbol u. Alright, so we have done replacing, or we have done choosing u. And moving on, step number 2 is we need to replace or rewrite the x with the u by using the u. So we can say from chapter 1, du over dx is equal to 3. Okay, and then we have from the algebra we get that dx is equal to du over 3. Okay, and we have we replace dx here with du over 3. Then we get the integral in u, integral 2 stay outside, eu du over 3. Alright, and continue with step number 3. We will integrate this function with their own with their own family for which type of function they are. Alright, okay, so taking this answer, right, so I want to bring over 3 here outside, so it become 2 over 3. Okay, so we have integral eu du. And from the last slide or from the last lesson, we know that integrating eu will become du, eu again. Alright, so we have the answer equal to 2 over 3 is still there, our constant eu just plus c. Alright, okay, done. So lastly, last but not least, remember to put back your u. So step number 4, last one. Okay, so the last answer we have to replace u to 3x minus 1 will give us the answer equal to 2 over 3 e power of 3x minus 1, then plus with a c constant. Done. Okay, finish. That's it. Simple. So again, we will keep repeating using the same method of substitution. We can use also with the e function, and that's how you use substitution method with the e function. Alright, so here I have 3 more examples. So in each of these 3, try on your own or with your friends for each integrate. Okay, so if you understand this topic, you should be no problem with the last one for logarithm. Alright, so that's all for today's video. Next video number 3, we will examine the ln function the last one, the last part, ln. So ln, I will say, not very tough, very straightforward. You should not have an issue with that. But don't worry, we still can apply the formula of the logarithm. All right, and that's all for today's video. And again, hope you have a wonderful day ahead, and see you in class. Bye.